In the last video, we have got the correct path from the active unit to the position where we are clicking. In this one, we'll be following this path. Let's start. Let's get to our code and let's apply it. So to follow the path, we are getting here, our path here is the current path. We are storing it here where we are finding the path. So actually by the default current path will be empty list. Let's write here a new, so we'll initialize it immediately. So imagine we have this list where we have all of these nodes, and each of these nodes has a position. So to keep a track at which node we currently are, we need to have some indexing here. We need to keep here some global index. So create here under manager private int, and we'll call it current path index or current node index, m_current node index. Okay, and by the default it will be 0, so we'll be starting at the first. We'll be going to the first node. Okay, so in our update, this will need to be changed. Okay, I think I'll just simply remove it. Everything I will remove. Yeah, let's remove everything. We'll start clean. So we'll get our current node, which we should follow. So let's write your node, current node, and it will be our current path. All right, and m_current node index. I don't know why we are calling everything current. Why we decided to call everything current node, current path, current node index. We can just simply call it follow path, for example, not the current path. I'm going with this naming. So let's get our current node. Okay, now let's get a position where we need to this node. Okay, so let's write your vector tree and target position. This will be in the new vector tree. So what's the position where we want to move? That's our current node and x. That will be the left bottom corner, but I think it will be better to move to the center position. Or actually, go with the x, and you will see how it will look like. And then we'll change it for the center x and y. So go again with the current node and y position. That's the target position where we need to move the current node. Now we will determine direction to this position. So write your vector tree and direction, and direction will be your target position minus your position, transform position, and you will normalize it. Okay, and now you can move. So transform.position plus equal direction multiplied by your speed, m_speed multiplied by the time, delta time. This will create a movement. And now, if you are close enough to the node, to this node where you are moving to, so if the vector tree and distance between you, so your distance, I will just move it inside. If the distance between you, so your transform position and the target position, comma here, and target position is smaller than some threshold, let's say smaller than 0.15, okay, 0.15, then increment your node index, m_current node index plus plus. Okay, hopefully this makes sense. So if I am on the position 0, 0, that's my current position, or that's my current node, and my next node in my path is 0, 1, the next position is 2, 0, and the next position is 3, 0. All right, so that's in my list. So my current node index is in index 0. So I need to move from 0, 0 to 1, 0. Okay, and the index 0. If I am close enough to this position, so if my x here, as I'm moving, is close to the 1, then this distance, I'm checking distance, I'm incrementing 0 to 1. And that will be my new current node where I want to move. So now I will be moving from 1, 0 to 2, 0. And it will, again, I will be moving. If I will be close enough to 0, I will increment 1 current node index to 2. This will be my current node, and I will be moving to 3, 0. Okay? Hopefully this makes sense. Okay, but you don't want to increment it forever because we will run out of the nodes and we'll reach the final position. So to not get issue, we will verify also before all of these checks if the path is valid, on which we are currently moving on. So I'll create here a new private method. Okay, so it will be private, will be under this one here. Okay, and we'll be returning bool. So bool, and we'll call it isPathValid. isPathValid. Okay, and from here we will return the path is valid if the current path count. So if we have the nodes inside, so if the current path count is larger than 0, so we have some path, and m current path index is smaller than m current path count. So we are in the boundaries of our list. Okay, we always make sure the current node index is smaller than current path count, because if we will increment here. So if our length of the list, we have 3 items, right? So we have 1, 2, 3 items in the list, and the current node index is currently index 0. This means with the index 0 I can access the last item, right? That's the index of 0. But when we'll increment now next time, this will increment to 3. And if I want to get now the node from the list here, there is no node on the index of 3, right? It is 1, 0, 1, 2, 3. There is nothing. So this will get me error. So that's why I will be checking here if the path is valid. So if I didn't increment it out of the boundaries of my list. Okay, and I will be checking it before we'll do anything here. So up here we'll write the if statement. I will check if the path is not valid. So exclamation mark if the path is not valid, brackets, then m destination is equal to null. Well, actually, we are not doing anything anymore with the destination if I'm thinking about it. Destination is null. We don't need to even store the destination here. Okay, let's keep destination to null and return from here. But as I said, we don't really need to know the destination here. Okay, so I could get rid of it. But maybe I will need it still because I need to keep this information for some caching or something. Yeah, keep it for now. I will decide later. Okay, but as you see, we really just getting this destination here, and we're just determining the path, and then we are using the path. We are really not doing any operation anymore with the destination. So yeah, let's keep it here. But notice that we don't need it so far. Save this, and we can test it out. Now our warrior should move on the left bottom position of each node. So first I will move this worker away, so it doesn't blocking me. So let's move the worker here. Let's play the game, and now the warrior should follow the left bottom position of each node. So when I look at the warrior and I will move here, you see it's following the left bottom position. Exactly. It doesn't want to go up here. Why? Okay, so we have some issue in our code. Let me try it one more time. Okay, so if I will move here, it's going there, following exactly. When I will move here, it's going there. All right. But doesn't want to go back for some reason. Is this position invalid or? Let me check it out. Okay, so let's get back to our code. And okay, we are incrementing and getting the node. Okay. We are never resetting the index, so the index will stay outside of the boundary, so we'll always be returning here after a few first moves. So yeah, we need to reset the index. So every time we'll find a new path, we should reset the index to 0. So m current node index is equal to 0. Now we should fix it. Let's save it. Let's get back, and now it should move correctly. It looks weird because we are always moving to the left bottom corner of the node, so it looks like I'm going backwards at the beginning. But what this warrior is really doing is moving just to the left bottom position of the node. That's where we are leading the warrior, and then it's following the left bottom positions like this. It looks not good. So what we can do, instead of using the left bottom position, as we are using here the target position, we can use our center position. So center X and the center Y, which is the center of each node. Okay, we can save this, and now the warrior should move in the middle of the node. So this should already much better. So when I will go and here, this looks already much better. And we are following the exact path. You can see I'm nicely avoiding all of the obstacles. I'm not moving, I'm not facing, when I'm moving to the opposite position, need to still adjust the code to face the car, and there are some issues that I'm spamming the clicking. You see I'm spamming the clicks, it doesn't work that well. Let's move the warrior outside of the boundaries here, so we can move outside. So let's say here, and also adjust our camera to point on the warrior. So let's get the warrior main camera here, move it to the warrior. Let's play the game now. So we have more space to move. Okay, this actually works quite nice. We are avoiding the obstacle. As I said, it doesn't work that well when I'm spamming the position on the one spot, so we need to still do something about it. But yeah, we can avoid obstacles, and that's the most important. As you see, we are moving the center of each node. And yeah, perfect. So it works partially. So let's fix small things in the next video. See you there.